Do you know what calculus notation is trash? So if you think of the definite integral, right, that's trying to find the area under the curve of some function. And the way we do it is we look at a Riemann sum. We chop it into some number of rectangles, and we say, let's add up these rectangles that are going to approximate the area under the curve. So you have your height of the rectangles, which is f of x evaluated at some xk, and you have the base of that rectangle, which is delta x. And then you add up those rectangles, and you get an approximation. As n gets big, those rectangles are going to become a better and better approximation. So if you take the limit as the number of rectangles goes to infinity, you get the definite integral, which is beautiful notation. As we know, when you take the limit, Greek letters turn to Latin letters. Instead of a sigma is Greek s, we put an s in front. Delta x becomes dx. But the notation is still reminding us that you're talking about area. Your infinitesimally small base, that's your dx, and your height, instead of f of x at some sampling of points, is f of x at every point from the interval a to b. So for every x value between a and b, you're taking a height and you're multiplying it by an infinitely small base. Beautiful notation. But then, when we're using the indefinite integral, that's now all of a sudden supposed to mean find the general antiderivative? No, that is nonsense. The definite integral can be evaluated using the antiderivative, not by definition. There's a theorem. There's a fundamental theorem that allows us to do that. You can't just say, oh yeah, because of this, we're going to use the indefinite integral to mean just find a general antiderivative. That is not what it means. Why is the s there? The s is a sum of rectangles. You're like, oh yeah, we're summing up this guy, but there's no bounds and there's no rigor, and we're just going to say this means find the general antiderivative. No. That is nonsense. That is trash. And you, sir, you indefinite integral are confusing students into thinking that somehow the definite integral is a statement about an antiderivative when it is not. It is a statement about area that requires a fundamental theorem to equate to an antiderivative. So you, indefinite integral, are some garbage notation. End of rant.